Colby, 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 math.com.
Today we learned how to make scatter plots. We learned about lines of best fit, positive and negative correlations. I'm going to do problem 1 with you on the support video. It says to draw a scatter plot for the data, then if possible draw a line of best fit. If there's a correlation, we can draw a line of best fit. If it appears to be no correlation, of course there would not be a line of best fit. We've got the width of a river and the water speed passing through the river at that particular width. To me it seems like the dependent variable would be the speed of the water, and the independent variable would be the river width. So I'm going to set up my axis labels that way, with river width on the x-axis, river width in meters, and the y-axis will be water speed. It's hard to do this on a writing tablet, so I'm going to do my best. It'll be easy for you to do it on your paper, but if this looks funny, that's the reason why. Water speed in kilometers per hour. So then we can just start plotting the points. But one of the reasons I chose this for the video is I find often that students have trouble with scaling their axes. This maybe is something you've done a lot of up to this point. So if we look at river width, our data is as low as 15 and as high as 45. Of course, the intersection of the x and y axes would be the origin, so that's going to be 0 by definition. And you look at how many lines you have to work with. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertical lines, and my data goes up to 45. So I'm just going to make each one 5. But in order to not clutter my labels, I'm going to show every 10. So this is 10, 20, 30, 40, and 50 meters. The units are already in the axis label. And the y-axis is a little bit tougher because looks like the lowest speed is 3 and 9/10. The highest speed is 12 and 6/10, and I've got 10 lines to work with, but I need to squeeze in all the way up to about 13. So I'm going to make a break in that axis, and if you want to see an example of a break, you look at problem number 5 on the back of your assignment, and you'll see that there's a little break. So a break looks like this, and that tells the person looking at your graph that yes, this is 0, but I'm going to skip from 0 to whatever my first data value on my y-axis. I'm going to go ahead and start with 4, even though this is a bit below 4, because I can just plot 3.9 just tiny bit below 4. So this will be 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. That'll let me fit in everything all the way up to 12 and 6/10. I'm going to plot the first couple data points. 15 meters, which would be right here. 12 and 6/10 would be a little bit above the midpoint here, so that's the first data point. The next one, when the river is 18 meters, so about 3/5 of the way from 5 to 15 to 20, 18 and 10.7. 10.7 would be probably right about here. It doesn't have to be perfect, it's just, do your best. And then I'm going to ask you to do the rest of them during the pause, and then come back and we'll talk about the line of best fit and what it means. And I'll also give you a little hint on problem number 2.
Paused.
I'm going to try to use a fast motion feature, so I'm going to plot these without talking and then try to speed it up so this video isn't overly long. Okay, that's my my best effort at plotting those points, and now there's clearly a correlation in the data. As the river width increases, the water speed decreases, and so I'm going to try to draw a line of best fit. And you do that by let's see, you try to draw a line through. If you can draw it through several of the data points, that's great, but even more important than that would be you want to have as many points that are not on the line above the line as there are below the line. And so I've tried to draw my line, so I have these 3 points a bit above my line, but then I have these two below and quite a bit more below than these are above, but they sort of balance out. There's actually a method called linear regression that you learn in more advanced math classes, but for this year we're just going to eyeball it, and that's sufficient for our line of best fit. This problem doesn't ask you to do so, but I'm just going to remind you that this is a negative correlation, because I find that on this particular assignment, students often forget to include that information for problems 4 and 5, but you are asked to describe what kind of correlation you find in 4 and 5, so remember to do that. And then we've drawn our line of best fit, and so we're done with this one. I just want to mention that problem number 2 asks you to use your line of best fit to make a prediction, and that's what's nice about having a line of best fit. I can now, for any river width, I can go up to the line and predict what I think the water speed would be. And so for 35 meters, if I follow that up to my line and then follow over to the y-axis, it looks like it would be 7 or just a little bit above 7 for the water speed. Okay, I hope that helped with the homework. I'll see you tomorrow.